So we're going to continue with our discussions about barrier synchronizers. Now we're going to focus on the Java phaser, looking initially at its structure and functionality. So the Java phaser is the third type of barrier synchronizer that's provided by Java. It allows a variable or fixed number of threads to wait for all the operations performed in other threads to complete before it proceeds. So it's somewhat like the other barriers, although, as we'll see in a second, it's a bit more flexible and dynamic. One of the human-known uses I've talked about before is having different work crews with different numbers of workers coordinating to build a house. This is an interesting model of a barrier synchronizer because it's well suited for variable-sized cyclic entry and/or exit barriers. So it supports all the three different models, and it also supports variable-sized capabilities. The number of parties can vary dynamically, so you don't have to predefine ahead of time how many parties there are, but they can shrink and grow over time. You can also use a phaser for fixed-size barriers, but honestly, it's probably overkill, because if you need a fixed-size barrier, you're probably better off using the cyclic barrier, which has a simpler, much simpler interface. And if you look carefully, this is a car with hundreds of seat belts in it. So it says overkill. Well, I have one, but you can have 200. So sometimes it's just not worth having all the excessive pieces. The phaser doesn't implement any particular interface. It's just a class that stands alone. It does not apply the bridge pattern. It doesn't use the abstract queued synchronizer framework, so it's its own thing. Instead, it defines various fields that are used to implement the phaser semantics. In particular, there's one field that's called the state field, which we'll talk about. The primary state representation holds 4 bit fields. If you're familiar with the concept of a bit field, it's basically just a way of packing bits or bit sequences into an integer or a long. In this case, it's a long. One of the bit fields, bits 0 through 15, keeps track of the number of parties that have yet to arrive or hit the barrier. So you can see that those are used to keep track of that. There's also the number of parties that are required to wait. And so that's kind of like the total count. That's bits 16 through 31. There's the phase, which is the generation of the barrier, because barriers can be reused because they're cyclical, so you keep track of which phase they're in. That's bits 32 to 62. And then there's also terminated, which is used if the barrier has been shut down. And as you can see, this is being stored in a 64-bit long. So we have a volatile long called state, which has 64 bits. And all of these values are packed into this atomic field. And these bits are updated using compare and swap operations. So this is a very, an intentionally very low-level implementation meant to be super efficient, and not the kind of thing that you would want to write unless you're really trying to economize the expressivity and make this thing be very, very space efficient and time efficient. Most people wouldn't want to write code like this. So that one of the things that is complicated is actually looking at the source code for the phaser, because it uses all this bit manipulation under the hood to do those kinds of operations. Okay, so that's the overview of the phaser in terms of its structure and functionality.